Hey guys, Mr. Mackenberg here. In this video, we're going to look at solving application problems involving systems of equations. So in this example, we're going to be taking a look at population, and the table below is going to show the populations for San Francisco and San Jose in thousands. So in 1980 for San Francisco, when we see 679, that really means 679,000. And in 1990, when we see 724, that really means 724,000. And what we want to do is compute a linear regression model for the population of each city. So I'm going to use my calculator, and I'm going to type all of this data into my calculator. Now, as I'm typing this into my calculator, I'm going to let 1980 be a t-value or an x-value of 0, meaning that 1990 would be a value of 10, 2000 would be 20, 2010 would be 30, and then 2015 would be 35. So those are the x values that I'm going to use in my list 1 in my calculator. So I'm going to start with San Francisco. So I'm going to hit Stat, Edit, and I'm going to enter in my data from my lists. So in my list 1, that's going to be my x values or my t values. And we said we were going to use 0, 10, 20, 30, and 35. In our list 2 is where we're going to put all of our populations. So I've got all of those populations typed in. Now I'm going to hit Stat, go over to Calc, and we're doing linear regression, so that's going to be option number 4 in there. I'm pulling my data from list 1 and list 2, so I'm going to go down to Calculate. And I'm going to round these off to 2 decimal places. So my A value is going to be 4.94, and my B value is going to be 676.01. So then the equation we end up getting for San Francisco is y equals 4.94x plus 676.01. And then I'm going to go back to my calculator, and I'm going to do the same thing except using San Jose's data. So back to my calculator, I'm going to hit Stat and Edit. I left the years in there, but I'm going to enter in my new populations because now we're looking at the city of San Jose. So I've got those populations typed in. I'm going to go Stat, go over to Calc, and linreg number 4. Pulling my data from list 1 and list 2 again, so I'm going down to Calculate. I hit Enter, and I'm going to go 2 decimal places again. So we've got an A value of 10.65 and a B value of 653.54. So then for San Jose, the equation we get is y equals 10.65x plus 653.54. Now for part B, we want to figure out when the population of San Jose surpassed the population of San Francisco. So we're going to use those linear models that we just created, and I'm going to use my calculator to help me out. I'm going to graph these out and look for their intersection point. So in my y equals, I've got both of those equations typed in. For my y1, I've got my equation from San Francisco's data, and for my y2, I've got my equation from San Jose's data. I did adjust my window. For my x min and x max, I went from -5 to 40. For my y min and y max, I went from 500 to 1200. When I hit graph, we're going to get a picture that looks something like this. We're looking for the intersection point, so I'm going to go second, trace, and option number 5, intersect. I'm going to go close to this intersection point, and then I'm going to hit enter 1, 2, 3 times. So we get an x value of about 3.94, so almost 4 years, because remember, x represents years. We started in 1980, so 4 years later would be 1984. So San Jose's population has been greater than San Francisco's population since 1984. So in this example, we're going to be looking at equilibrium price. We're part of a manufacturing company that is producing a new line of tennis shoes, and we've determined that the production and price of the new shoe should be geared towards the equilibrium point for the system of equations down below. Now that system of equations represents supply and demand, where P is the price in dollars and X is the number of pairs of shoes in millions. So we've got a demand curve and we've got a supply curve, and both of those are P equals equations. So in order to solve this one, I'm going to do substitution. Since I've got P equals in each one of my equations, then what I can do is take the P in my top equation and replace it with this 35 plus 20x. So we would get 35 plus 20x is equal to 160 minus 5x. I'm going to subtract the 35 from the right-hand side, so we get 125, and I'm going to add that 5x over to the left-hand side, so we get 25x equals 125. Now, if I divide both sides by that 25, then we get an x value of 5. Now remember, x represents the number of pairs of shoes. So x being 5 means that we should produce 5 million pairs of shoes. But we also want to figure out our price. So we need to take that x value and plug it back into one of our equations. And it doesn't matter which one we choose, so I'm just going to do the top one. So we've got p equals 160 minus 5 times 5. Now 5 times 5 is 25, and if I take 160 minus 25, then I'm going to get 135. And remember, p is going to represent our price. So each pair of shoes is going to cost $135. That's going to be it for this video. Thanks for watching.